Dari, hello. It's the middle of May 2021 and today we're going to look at the Cromix boot process, at the Cromemco Cromix boot process. This is a companion video to the other video which actually shows you the boot process on the screen. Okay, so what we're going to expect is that you've got a system which has got a Z80 and a 68,000 CPU on one card. So that's either the 68,000 or the 68,010 Motorola card. And you've also got a hard disk, and that hard disk is going to be accessible via the STDC disk controller. So we're going to try and explain how we get from the machine startup to it actually booting. The first thing to look at is the format of the hard disk. So the hard disk controller, the STDC disk controller, can support up to 2 MFM hard drives, and it's unconventional for the time in many respects. The first is that it's got its own little computer and memory on the card itself. So it's a fully functioning Z80 computer with its own memory, and it uses that to manage read and write transactions to the hard drive, and it also does this on a track basis, not a sector basis. So a track is exactly 10k in length, and there's some bytes before that 10k of data and some bytes afterwards, including CRC and stuff like that. But it doesn't use the conventional sector formatting that hard drives would normally use. It uses track formatting, and it would store that whole track in a buffer in the on the controller itself. So the idea is you're going to get much faster throughput, etc. But let's look at the actual physical disk. The physical disk has got a number of partitions on it, and I'm just going to show you the one partition here. Again, this is all as I understand it, so we're hoping it's gospel, but it may not be. On track 0, you've got an indication, a description of the rest of the disk. And we're actually going to be looking at a single partition which starts here, for example, in this example, at track 1, and say finishes at track 50. So by track, this disk has got a number of surfaces. So you normally refer to the disk with a number of cylinders, and that cylinder's got a number of surfaces. So I might say seek to track 50, surface 0, seek to track 50, surface 1. Because the disk got a number of platters, and each platter's got 2 sides to it. So if it was a 2-platter disk, you'd have surfaces 0, 1, 2 and 3. This is the partition layout for Cromemco. At the beginning of the partition is a boot block, and I believe that the boot program can be up to 8k bytes, but the track is conveniently 10k, so the boot block is obviously going to fit within that track layout. Inside the partition itself, you've got an initialized and then formatted area with the cromix.sys file, the master operating system file for Cromix. So that's the layout of the physical disk. I'm going to now go on to how does the machine actually start. So when you power on the machine, the Z80 is a control, the Zilog Z80 is a control, and there will also be a monitor ROM sitting on the diskette controller, not the STDC hard drive controller, but the diskette controller. So that monitor is always present at the hex address C000. And indeed you configure on the old Z80 only card a jump address, which is where does it jump to when it powers on, and you'd set that to C000. In order for all of this to work, in order for the boot process to work, the CPU has to start up, and it's going to need to have some RAM and memory to use. So in the olden days, when you only had between 0 and 64k, but you wanted a 64k memory card in there, you had to arrange that the instant that the machine powered on, the ROM was available, but not all of the RAM was available, otherwise there'd be an obvious conflict. So I think the S100 way of doing that was with a physical line called the phantom line. So you could buy a 64k memory card, and you could say, Mr. Memory Card, please, when the phantom line is asserted, then make part of that 64K space deselected, and when the machine started up, the floppy disk controller would have the C000 selected, and therefore the machine would start, the CPU would start up, Z80 would start up, it would jump to C000 in the ROM and not in the RAM. And then when it had done all its stuff, there'll be a way of deselecting the phantom line, and then the full 64K would be available. That was to give you the full 64K. Obviously, if you only had a 32K system and the ROM is sitting up at C000, you've got no problems, you don't need that phantom line. But quickly people realised, seems to be the story of the IT world, that the 64K full address space that was there wasn't enough. So that's where the phantom line came into play. Now, Cromemco didn't use that. They used what they called bank select, which was the output to a port 40. So they placed a different constraint on memory manufacturers, was please make a memory card into which you've got this bank select. So you could have a 64 memory card which could, say, be split up into a number of banks. Let's say it's two 32K banks, and on power on, let's say, the first 32K of memory is available, but the rest of the 32K memory is not available. So in the old days, you'd only have a 64K card. I'm showing you an example 256K card. In the 68,000 era, the idea was you could have an address space of up to 16 megabytes, not just 64K. And it used a completely different addressing scheme. So when Cromemco made the jump from Z80 to Z80 and 68,000, they produced a series of memory cards which had this extended memory capability, but they also wanted to keep along with the original Z80 design. So when the bigger than 64K memory cards started up, they would typically start up in Z80 mode, and then they would flip to this other mode, again via a series of port commands. So it was quite a complicated procedure. And when you bought a Cromemco memory card, or one that would be compatible with the Cromemco systems, it would always start up as like a 64K card, and you'd have this idea that it would start up with RAM memory, only a part of which was available, with a hole so that the monitor could sit there. So anyway, back to our starting process. The Z80 starts up, the monitor's present, other memory is disabled, except a bit of RAM at the bottom, which the CPU is going to need to read and write to. The CPU jumps to C000, and at that point, the latest floppy disk ROM version, so I think that's version 3.1 something and above, they would know about the STDC hard disk controller. So at this point, the STDC is just sitting there. It's probably come alive, it's got its own firmware, and it's got its own ROM, so it started up. But the code to address it was stored inside the diskette controller. So you'd hit enter a few times typically, and there's a serial port on the diskette controller, and the initial monitor code is just looking for your input on the serial port, and it would, based on the fact that it expects you to hit the return key, it would figure out what your baud rate was. There were some options to set the baud rate to fixed, but there's a clever option which says automatically detect the baud rate. So the Z80 first of all determines your baud rate, and then prints a message on the screen saying Cromemco RDOS typically. And at that point you can issue commands, and the commands that you could issue would be something like BST0. So BST0 would mean B for boot, and ST0 would mean boot the 0th, i.e. the first partition on this disk. So the disks are numbered. A physical disk, the first physical disk on the controller, on the STDC controller, goes from STD0 to up to STD30. So you can have up to 31 partitions, and there's a special STD which is STD31, and that's taken to mean the entire first disk. And then you've got STD32 to STD62, and you've got STD63. So that's the first physical disk. That's how you would address the first physical disk, and that's how you address the second physical disk. So again, STD63 is a special device name which refers to the entire disk, in the same way that STD31 is a special name that refers to the entire first disk. And STD0 would be, in my little diagram here, this would be the first partition on the disk with STD0. So if I type in B ST0, it means boot the first disk here. And what does that do? That goes into the boot block. Now I was never quite sure whether the boot block was written in Z80 or 68000. Since you're in Z80 mode when you're in the monitor, I don't know when it makes the switch. Does it make the switch as the instant it leaves, or is the boot block written in Z80 code? Anyway, I never quite figured that out. So it reads the boot block here, and then the boot block tells it how to get to Cromix.sys. It reads Cromix.sys, and basically the system is up. Obviously, Cromix.sys doesn't need a few other files, but it's at this point where Cromix is up. So Cromix is not compressed. It's not stored separately in a special place like you might find with modern day Linux systems. It's just the file as is. Okay, I think that's the hopefully not too long-winded explanation about how the system is going to boot. Please watch the other video where you'll see an actual system booting. Thanks for watching.